Hi, welcome to another Dech Academy video. In this one, I'm going to be tackling question 21 of the 2013 math exam. And the question says, in the diagram below, PQRS is a rhombus and angle PSQ is 35 degrees. Calculate the size of angle PRQ. So you're told that this angle here, PSQ, is 35 degrees, and you're asked to find angle PRQ, given the fact that you've been told the shape is a rhombus. Now, a rhombus has a lot of properties, and these properties will enable us to find the angle alpha, or even all of its angles if that was a question. So I'm going to visit the properties of a rhombus before I start to solve the question. So the properties of a rhombus are listed as follows. It's a parallelogram with equal sides, and so that means, if you look at this sketch here, it means that its opposite sides are parallel. So those two sides are parallel, and this side are parallel, and it has equal sides. So all its sides have an equal length. That's what that means. It has perpendicular diagonals. Its adjacent angles are supplementary. Its opposite angles are equal. Its diagonals bisect interior angles. So I'm just going to visit the other properties. So let's start with the one where let's start with this one, the easiest one to get. Opposite angles are equal. Well, if you look at this shape, the opposite angles are x and q, so opposites in that sense, and p and y. So from that property, you can immediately tell that q is equal to x is equal to q, and p is equal to y. So the next point is that I'll touch on is that it has perpendicular diagonals. So if you draw the diagonals for this rhombus, i.e., join the vertices, the opposite vertices. So this is one diagonal. That should be a straight line, and this diagonal is telling you that the two diagonals are perpendicular to each other, so they make an angle of 90 degrees with each other. So that's that. So that's this point taken care of. Imagine if I extend this line here, I extend this line here, I extend this line here, extend this line here, extend this line this way, extend this line this way, extend this line, extend this line. Now, what is an adjacent angle? An adjacent angle is an angle that is right next to another angle such that they share a boundary. I mean, that's one way I'll define it, and an easy way to remember. So for this angle x, the angle adjacent to it is this angle here, and I'm going to call this angle alpha. Now, adjacent angles are supplementary. They add up to 180 degrees. And another way to see this is that angles on a straight line add up to 180 degrees. So x plus alpha must be 180 degrees, right? Now, if you look at the fact that this side is parallel to this side, if you remember from corresponding angles are equal. And that's a property you must have learned when you dealt with lines and angles and things like that. It means that, I mean, if you look at it this way, alpha corresponds to y. I mean, you might not be able to see it, but if I draw it this way, if I draw this for you, assuming these two lines are parallel, this angle and this angle correspond to each other, because you can see there's this line and there's these two parallel lines, and you can see that this line and this line make an angle, call this theta. Well, this line is parallel to this line, so it must make the same angle with the same line, theta. I mean, that's the idea, but I'm assuming you already know what corresponding angles are, so I'm just gonna make it obvious that alpha is actually equal to y, so that means this is actually y, so this is actually y. So what that means is that, as I said, x plus alpha is 180 degrees just because they're adjacent. But alpha is now y. That means x plus y is 180 degrees. So that means x plus y is 180 degrees. A general thing to remember is that, without even having to complicate things, this angle here, x, is equal to this angle here, q. So let's just call this x. Angle here, y, is equal to this angle here, p. So let's just call this y. Now, you can then see that a rhombus essentially has two different, in the sense that you have one angle x, which is also here, and an angle y, which is also here. Another thing to remember, and a way to summarize this point without confusing you, is that x plus y will always be 180 degrees, and x plus y will always be 180 degrees. So always know that. So that's this point taken care of. Diagonals bisect interior angles. So for this last point, it's best to use a different parallelogram. So say I have this parallelogram, assuming this was a rhombus, sorry, and this angle was, I'm going to call this now 2x, and you see why. From the rules I just showed you, opposite angles are equal, therefore this is 2x. So let me put this here, 2x. And say this angle was 2y. Because opposite angles are equal, this angle here is also 2y. For a rhombus. Now, diagonals bisect these interior angles. What does that mean? That means it splits them into two equal parts. So that means this angle here is going to be x, half of 2x. This angle here is going to be x. So together they add up to 2x. Similarly, this diagonal here splits this angle and this angle into two equal parts. So this part here is going to be y. This part here is also going to be y. And together they add up to 2y. So that should make sense. And I think that's all the properties for rhombus you really need to know for this question anyway. So now back to the question. You're given a rhombus and you're asked to find what the value of this angle alpha is, and you're told that this angle here is 35 degrees. So now we're going to use the properties I just spoke about to solve this problem. So if you recall, I mentioned that the diagonals of a rhombus bisect the interior angles. What does that mean? That means that we know that this whole angle here has been bisected. That means 35 degrees is half of this whole angle here. That means, and okay, let's put it this way. This angle is equal to this angle because the whole angle here is split into two parts. So that means this is also 35 degrees. That means this whole angle here is 70 degrees. So you can take, let me not confuse you, just keep it in your head. So this is 70 degrees. So, and remember, opposite angles are equal. So that means this is also 70 degrees. The whole angle here is 70 degrees. Let's call that 70 degrees. And adjacent angles are add up to 180 degrees. And from that, we could tell that this angle and this angle must add up to 180 degrees. So if I call this angle y, and I say that 70 plus y must be 180 degrees, that means y must be 180 minus 70. That means y must be 110 degrees. So that means y is 110, which means that the whole angle here, remember, opposite angles are equal. That means the whole angle here is also 110 degrees. And because this diagonal split this whole angle here into two, where alpha is one of the two parts, that means this is also alpha. And that means alpha is 110 divided by 2, which gives 55 degrees. And just to avoid the confusion, let's put it this way. So just that last step was as follows. We knew, or we determined that this whole angle here is 110 degrees. We determined that. And the diagonal was already drawn, and you're asked to find alpha. And we know that the diagonal, so that should have been drawn better, but we know the diagonal split the whole angle into two parts. What's 110 into two parts? That's 110 divided by 2, which is 55. That means alpha and this other angle here, which must also be alpha, are both 55 degrees. So alpha is 55 degrees, so that should make sense. We knew the whole angle is 110 degrees using the properties we just learned. And we know that the diagonal divides the whole angle into two parts. And then we're asked to find the value of one of the parts. Well, one of the parts is half of the whole angle, which is half of 110 degrees. So that's very easy. And that's the solution to the problem. So the angle asked for, which is PRQ, this PRQ here is 55 degrees.